Welcome back, everybody, for another deep dive. And today we're going to be taking a look at two really fascinating NASA missions that actually launched together just a few months ago, SPHEREx and PUNCH. And they're both going after some pretty big questions.
Yeah,
One peering back to the universe's earliest moments.
right.
The other one focused on our very own star, the sun.
And it's that contrast that makes them so compelling as a pair, right? I mean, we're talking about missions that could help us find the building blocks of planets, maybe even life, and at the same time protect astronauts on future missions.
Yeah, it's really quite incredible. So let's start with SPHEREx.
Okay.
I was reading that it's going to create a 3D map of the universe.
Uh-huh.
But not just any map, right? It's
Okay.
going to be using 102 different colors.
That's right. So SPHEREx is essentially going to be looking at the light from 450 million galaxies and 100 million stars in our own Milky Way galaxy.
Yeah.
But instead of just seeing that light, it's going to break it down into 102 different colors,
Okay.
which is what astronomers call a spectrum.
Why is that so important? Is it just to make a prettier picture?
No, not at all. Each of those colors tells us something different about what that galaxy or star is made of,
Okay.
what elements are present,
Right.
and even how those objects are moving. It's like taking a fingerprint, but for the universe.
So that helps us understand how galaxies have changed over time.
Exactly. We're looking back billions of years to see how galaxies formed, evolved, clustered together.
Right.
It gives us clues about the very early universe, which is a period we still know very little about.
And while it's doing all of that, SPHEREx will also be looking for water and other molecules that are frozen on these little interstellar dust grains. That's what really caught my eye.
Yeah, what's fascinating about those icy grains is that they're the building blocks of planets.
Mm-hmm.
So understanding what they're made of, where they are, helps us piece together how Earth itself got the ingredients for life.
Oh, wow.
And of course, it makes you wonder, are those same ingredients out there around other stars?
It makes the search for alien life feel a lot more concrete.
It does. And, all of this is linked to one of the biggest mysteries in cosmology, which is this idea of cosmic inflation.
Sure.
The idea that just after the Big Bang, the universe expanded incredibly fast.
It's like faster than the speed of light.
Faster than the speed of light.
Yeah, that's hard to wrap your head around.
It is, but by mapping the distribution of galaxies, SPHEREx can actually look for patterns that might support or challenge theories about inflation.
So SPHEREx is tackling some pretty fundamental questions.
It is.
But let's move on to PUNCH.
Okay.
I have to admit the name makes me think of something totally different.
I know, right? It sounds like a superhero or something.
Right.
It does. But PUNCH is actually all about understanding our own star, the sun. Specifically, its corona,
Okay.
which is its outer atmosphere, and the solar wind.
Now remind me, what exactly is the solar wind? It's not a gentle breeze, is it?
Not always. The solar wind is a constant stream of charged particles flowing out from the sun. Most of the time, it's not a big deal, but the sun can have these outbursts called coronal mass ejections, or CMEs, where it throws out a huge amount of energy and particles.
And that's where things get dicey for us here on Earth, right?
Yeah,
Our sources mention it can mess with our technology, especially satellites and even power grids.
that's right. When a CME hits Earth's magnetic field, it can cause what we call a geomagnetic storm.
Okay.
And these storms can disrupt radio communications, damage satellites, and in extreme cases, even cause widespread power outages.
Okay, now I'm really starting to see why we need to understand the sun better.
Yeah.
So how does PUNCH fit into all this? What does it actually do?
So PUNCH is actually a group of 4 mini-satellites,
Oh, wow.
and they work together to create a 3D view of the sun's corona and the solar wind. By tracking how CMEs develop and move through space, PUNCH is going to give us much better warning about when they might hit Earth.
So it's almost like a space weather forecasting system?
Exactly. And as we start sending humans further out into space to the moon and Mars,
Right.
this kind of early warning system becomes even more critical. We need to be able to protect our astronauts from those intense bursts of radiation from the sun.
It sounds like PUNCH is as much about protecting us here on Earth as it is about understanding the sun itself.
It is. And what's interesting is how both PUNCH and SPHEREx are pushing the limits of technology. I mean, think about it.
Yeah.
Trying to build instruments that can survive in space, handle massive amounts of data,
Right.
and still give us accurate measurements.
It's incredible what engineers are able to achieve these days.
It is.
But I imagine there must be some pretty major challenges involved, too.
Oh, there definitely are. For SPHEREx, one of the biggest hurdles is dealing with all that data. We're talking about an insane amount of information coming from those millions of galaxies and stars.
How do you even begin to process something like that?
Well, they're using some of the most advanced algorithms and machine learning techniques out there. It's almost like creating a superpowered cosmic librarian that can sift through all that information and pull out the most meaningful insights.
That's mind-blowing. So data management is one big hurdle.
Uh-huh.
What are some of the other challenges that they face?
Well, for SPHEREx, calibration is also incredibly important. Think about it. That telescope has to be sensitive enough to detect incredibly faint infrared signals from objects billions of light years away.
Yeah, and I imagine any little bit of interference could throw the whole thing off.
Exactly. They have to account for everything from temperature changes on the spacecraft to the tiniest movements of the telescope itself. It's a level of precision that's hard to even imagine.
It really highlights the incredible skill and dedication of the scientists and engineers working on these missions. It's like they're pushing the boundaries of what's even possible.
They really are, and those challenges are just as real for PUNCH too. I mean, coordinating 4 separate satellites, keeping them in formation, making sure they're collecting data in sync.
Yeah.
That's no easy feat.
That sounds like a cosmic ballet where everything has to be perfectly timed.
And then, of course, you have the constant threat of space debris and radiation,
Right.
which can damage the satellites or interfere with their instruments. They have to be designed to withstand some pretty harsh conditions.
It's amazing how they can plan for all those contingencies. But one thing our sources mentioned was how unpredictable the sun can be.
Yeah.
They were talking about how it's difficult to capture those really rare, high-impact events.
That's true. It's like trying to photograph a lightning strike. You have to be in the right place at the right time, but with the sun, you can't predict exactly when and where those bursts of energy are going to happen.
So there's an element of luck involved as well.
To some extent, yes. But the PUNCH team is using sophisticated models to try and anticipate solar activity as best they can. It's a combination of planning prediction and, yes, a bit of good fortune.
It sounds like both SPHEREx and PUNCH are pushing us to think bigger, to imagine what's possible, and then figure out how to make it happen. It's about so much more than just sending machines into space.
I agree. These missions are a testament to human curiosity and our desire to understand the universe around us. And the insights they provide could have ripple effects across so many fields, from astronomy and astrophysics to space weather forecasting, and even our understanding of life itself.
Before we move on,
Yeah.
I think it's worth pausing for a moment to appreciate the incredible amount of work, ingenuity, and collaboration that goes into these missions. It really is a testament to what humans can achieve when we set our sights on something truly extraordinary.
Absolutely. And the best part is we're just at the beginning of this journey. The data from SPHEREx and PUNCH will be analyzed for years to come, leading to new discoveries and insights we can't even imagine right now.
I, for one, can't wait to see what they uncover. But I'm also curious about how this knowledge will be used, how it might shape the future of space exploration, interstellar travel,
Yeah.
and maybe even the search for extraterrestrial life.
Well, that's a conversation for another time.
Okay.
But I can tell you the possibilities are truly exciting.
So we've talked about all the challenges of actually gathering all this data, but what about actually using it? I mean, we're talking about mapping millions of galaxies, tracking these huge solar storms.
Yeah.
How does that information help us, in a very concrete way? Like, how does it help with something like the search for alien life or protecting astronauts?
Yeah, that's where things get really interesting. Let's start with SPHEREx. Remember those icy grains that it's looking at? Those are actually the building blocks of planets.
Right.
And by studying them, SPHEREx can tell us, which star systems have the right stuff for planets and potentially, even life as we know it.
So it's not just about looking back at how the universe was formed, but it's
Yeah.
about using that knowledge to find places where life might exist right now.
Exactly. It's like having a cosmic treasure map guiding us toward the most promising locations for, future missions that are actually searching for life beyond Earth.
Okay, that is really cool.
Mm-hmm.
And what about PUNCH? How does understanding the sun's behavior help us with something like, say, sending humans to Mars?
Well, think about the biggest danger for astronauts traveling to Mars: radiation.
Okay.
And a big chunk of that radiation comes from the sun, especially during those coronal mass ejections that we talked about.
Right, those solar storms.
Yeah.
But how can PUNCH help with that? It's not like it can stop a solar storm from happening.
No, it can't stop them, but the data that it gathers could help us predict those storms more accurately.
Wow.
And maybe even design better shielding for spacecraft, to protect the astronauts inside.
So we could potentially plan missions around periods of low solar activity, or at least be prepared when those storms do hit.
Exactly. And as we think about longer duration missions, maybe even establishing permanent bases on the moon or Mars, understanding and predicting space weather becomes absolutely essential.
It's like we need to learn how to live with the sun, not just study it from afar.
Right. It's not as simple as just, slapping on some sunscreen and calling it a day.
Yeah, yeah, that's a good analogy.
Yeah.
We need to become a spacefaring species that can withstand the sun's power, but
Wow.
also use it to our advantage.
Definitely.
So I'm starting to see how these missions fit into this bigger picture,
Mhm.
but I'm curious about some of the more specific applications. Like, what kind of new technologies or innovations might come out of all this data?
Well, one thing is that the data from SPHEREx and PUNCH could be used to train, incredibly sophisticated AI models.
What kind of tasks?
Well, imagine AI systems that can predict space weather with incredible accuracy or even navigate spacecraft autonomously dodging space debris and solar storms.
Yeah, so we're talking about AI that can make space travels safer and more efficient.
Exactly.
Yeah,
That could be a real game changer for future exploration.
it really could. And then I guess understanding the sun's behavior also helps us protect our infrastructure here on Earth too,
Oh,
right?
absolutely. Because, those geomagnetic storms that we talked about, they can knock out power grids, disrupt communications, cause all sorts of chaos here on Earth. So by improving our ability to predict and prepare for those events, PUNCH could actually help make us more resilient here on Earth as well.
So it's like we're learning to live in harmony with the cosmos instead of just being at its mercy.
That's a great way to put it. And that's what's so exciting about these missions. They're not just about collecting data. They're about applying that knowledge to solve real-world problems.
Right.
And to push the boundaries of what's possible.
They're inspiring us to think bigger, to imagine a future where humanity is not just exploring space, but thriving in it.
I agree.
It's kind of funny. We started this deep dive talking about these
Yeah.
two missions. One looking way back to the beginning of the universe, the other one focused on our sun.
Yeah.
And yet they're both sort of connected to this bigger question of, are we alone?
It really highlights how interconnected everything is, doesn't it? I mean, the origins of the universe, the formation of stars and planets, the conditions for life to emerge, it's all part of the same grand cosmic story.
So how exactly do SPHEREx and PUNCH contribute to that search for life beyond Earth? Are they going to, find aliens hiding out in some distant galaxy?
Well, maybe not directly, but they will provide some crucial clues. So SPHEREx, with its, detailed map of interstellar ice and water, can help us pinpoint those star systems that have the right ingredients for life as we know it.
So it's kind of like narrowing down the search, right? Highlighting those planets that are most likely to be habitable.
Exactly. And PUNCH, by helping us understand the sun's behavior, gives us insights into how other stars might impact the development of life on their own planets.
Because if our sun can throw these huge tantrums in the form of solar storms, I imagine other stars can too.
Absolutely. And depending on the star's activity, those planets might be bathed in constant radiation, making it much harder for life to get a foothold.
So we're not just looking for planets in the so-called habitable zone around a star.
Yeah.
We also need to consider the star's temperament, so to speak.
Precisely. And that's where missions like PUNCH come in. By studying our own sun in detail, we can start to build models for how stellar activity might influence the habitability of planets around other stars.
It's like we're learning the rules of the game, figuring out what makes a planet truly suitable for life.
Yeah, and that knowledge could totally revolutionize the search for extraterrestrial life. Imagine being able to point our telescopes at a distant star system and say, based on what we know about that star and how it behaves, that planet over there has a really high probability of hosting life.
That would be incredible. It feels like we're on the cusp of some really big discoveries.
We are. And it's not just about finding life elsewhere. These missions also challenge us to think about, our own place in the universe. They kind of make us realize that we're part of something much bigger than ourselves, something ancient and awe-inspiring.
It's that sense of wonder and curiosity that drives us to explore, doesn't it?
Yeah,
To keep pushing the boundaries of what we know and what we think is possible.
absolutely. And SPHEREx and PUNCH are prime examples of that spirit of exploration. They're a real testament to human ingenuity, collaboration, and our, relentless pursuit of knowledge.
I don't know about you, but I'm feeling pretty inspired right now. It's like these missions have opened up a whole new universe of possibilities, both scientifically and philosophically.
I agree. It's a really exciting time to be alive, to be witnessing these incredible feats of engineering and scientific exploration.
And who knows what the future holds?
Oi.
Maybe someday, thanks to the knowledge gained from missions like SPHEREx and PUNCH, we'll be sending humans to those distant star systems searching for life among the stars.
That would be truly remarkable. But for now, we can marvel at the incredible achievements of these missions and the dedication of all the people who made them possible.
Well said. And on that note, I think it's time to wrap up our deep dive into SPHEREx and PUNCH. It's been an incredible journey exploring the origins of the universe, the mysteries of our sun, and the, tantalizing possibilities of life beyond Earth.
It's been a pleasure.
To everyone listening out there, thank you so much for joining us on this cosmic adventure. Keep looking up, keep asking questions, and keep that sense of wonder alive. Until next time, keep exploring.